Thank you, Wendy. Good day, mates. Welcome to the 4th International Congress on Physical Activity and Public Health. Wendy, Adrian, and the rest of the organizing committee have planned an exceptional event. Over the next 3.5 days, we have approximately 65 scientific sessions, 30 symposia, 16 workshops, 10 tutorial sessions, 7 keynote addresses, plus poster sessions and networking time. So each of us spends about 44 hours on this important and exciting topic, physical activity and public health. It will be so much fun. And I'm so happy to be here and to be part of it. With so much ahead, we have to pace ourselves. And therefore, I have decided to start us off with some simple stories. Stories in which physical activity is the leading character. So this afternoon, I am the narrator. I am not a purposefully deceptive narrator, but I have my biases. I have a public health bias, and so I'm much more likely to talk about populations and prevention than individuals and treatment. As Wendy said, I prefer quantification, and I have made assumptions and estimates to come up with some numbers for us today. We all have a cultural bias, that we're deeply influenced by the culture in which we live and in which we grew up. So my stories have an American flavor, but I look forward to your stories over the next several days with their diversity of flavors. We probably all share a bias in favor of vigorous physical activity. We love it, and we wish everybody would do it. But we have to ask ourselves if our affection for vigorous activity has biased our understanding of the science or our efforts at activity promotion. Today's stories are a 200,000-year-long meter stick, vigorous longshoremen, moderate butts in, and the unthinkable happens. The withering, sick populations, and the character in full. These stories are set in the ancient past, 3 of them in my past, and 2 of them take a peek into the future. A 200,000-year-long meter stick. The first human species emerged somewhere around 3 to 5 million years ago. Australopithecus, Homo habilis, and others. Homo sapiens, that's us, appeared on the scene about 200,000 years ago. Now, if these 200,000 years are stretched out along a meter stick, all those things that seem like they happened such a long time ago, the most recent ice age, the new stone age, the domestication of animals and the development of agriculture, the bronze age, are all crammed into the final 10 centimeters. The most recent 100 years are represented by the last 1/2 millimeter. Now, for most of those 200,000 years, we were very active. Some anthropologists have postulated that humans' unusual capacity for long-distance running was crucial for survival. Our upright posture and our efficient cooling mechanisms enabled us to capture faster but less durable prey. Hunting animals, searching the environment for edible roots and berries, maintaining their dwellings, migrating with the seasons. Life was precarious and required lots of physical activity. Anthropologists estimate that early humans consumed about 3,000 kilocalories a day. Now, to compare with humans today, who are a bit larger, let's assume about 3,200 kilocalories a day. And from that, we can estimate how much energy they expended in physical activity. Assuming a basal metabolic rate similar to ours for about 1400, and a metabolic response to food, which is the energy we expend ingesting, digesting, assimilating, and metabolizing the food. That's about 10% of the total. That's 320. So it leaves about 1,480 kilocalories a day for physical activity. Just for comparison purposes, a minimally active person expending about 2,000 kilocalories a day would expend only 400 kilocalories for physical activity, less than a third of our estimate for early humans. Still, how much activities did our ancestors do? If we assume 8 hours for sleeping with no physical activity, to expend 1,480 kilocalories a day in the remaining 16 hours, a person of average size would move at an average MET level of about 2. That doesn't sound too hard, but it's still fairly abstract, so let's make a couple more assumptions. 16 hours at a MET level of 2 is roughly equivalent to walking about 32 kilometers. Most of us have expended that much energy or more on many days, but few, maybe none of us, have performed that much physical activity day after day after day, year after year after year. Our ancestors were not superhuman, but they were very physically active. Now, this story is interesting, not only because of the high levels of physical activity performed by our ancestors, but because over the millennia of evolution, activity became inextricably linked with the structure and function of organs, tissues, cells, and organelles. Beyond the obvious connections between physical activity in the cardiovascular and musculoskeletal systems, physical activity influences insulin sensitivity, mitochondrial density, endothelial function, blood coagulation, immune function, autonomic balance, neuromuscular coordination, enhanced neural circuits, and more. For hundreds of thousands of years, physical activity kept us alive, not only by enabling us to obtain food and protection, it has kept us alive by assuring that our bodies and our minds functioned appropriately. Our second story is about vigorous longshoremen. Knowing what we know today about the benefits of regular physical activity for cardiovascular health, it's hard to imagine that in the middle of the previous century, it was commonly believed that too much or too vigorous activity was bad for the heart. Aside from the spike from the influenza pandemic in 1989, mortality rates from infectious diseases gradually declined, whereas the mortality rate for heart disease rose steadily through the first half of the century. By 1950, nearly 40% of all deaths in the United States were caused by heart disease. None of the risk factors known today was established, and many thought strenuous activity was bad for the heart. There were, of course, a few scientists with foresight. Paul Dudley White, President Eisenhower's physician, was one. Per Olof Ostrand and a large number of Scandinavian physicians and exercise scientists were others. In 1967, Ostrand predicted that science would demonstrate that regular physical activity was good for the heart, but he thought it would take us 100 years. Jerry Morris and then Ralph Peffenbarger were just beginning their seminal epidemiologic studies, but most people still believed that too much or too strenuous activity was dangerous. Longshoremen load and unload cargo onto ships. It was and has always been among the most strenuous occupations. Workers and their families must have been anxious about the vigor of their labor. And in 1951, the Longshoremen's Union in San Francisco organized a multiphasic screening program, and about 80% of the longshoremen participated. The San Francisco Longshoremen Study, with more than 3,500 participants, lasted from 1951 through 1972. It was one of many occupationally based multiphasic screening and cohort studies that helped implicate smoking, hypertension, hypercholesterolemia, and eventually inactivity as risk factors for heart disease. My admiration for these early cohort studies increases when I recall the tools that were available. Jerry Morris commented that record keeping and tallies for his early studies were all done by hand. In 1953, IBM produced its first commercial computer, the IBM 701. At several hundred kilos and the size of a small car, it didn't fit easily into your pocket. Over the next 24 months, IBM sold 19 units. Not exactly the Apple iPad. Software packages like SPSS and SAS were far in the future. The Longshoremen study added something that none of the other studies of the time did. In 1953, just a couple years into the study, the energy requirements of various tasks were measured, making it possible to estimate the actual work energy of their tasks. And 40% of the men performed tasks that required 5 to 7 kilocalories a minute, which is about 6 minutes. Recall the estimated energy expenditure of early humans. If we assume 5 working days and 2 non-working days per week, the longshoremen performing these high-energy tasks were expending an average of about 3,000 kilocalories a day, just slightly less than our estimate for early humans. The longshoremen with lower energy tasks, the comparison group, expended an estimated total of 2,400 kilocalories a day. For comparison purposes, a person performing about 1,000 minutes a week, the high end of the recommended range of the US guidelines, might expend about 2,400 kilocalories a day. In 1970, as the Longshoremen study was drawing to a close, I purchased this medical textbook, still extolling the value of resting the heart. In 1974, I was given this slide rule to do my calculations when I joined the CDC as a young epidemiologist. That same year, just a few years after I bought that textbook, and just a couple years after the Longshoremen study had concluded, I attended the American Public Health Association meeting in New Orleans. One afternoon, I went to a session on cardiovascular epidemiology, and I recognized the names of some of the epidemiologic luminaries as they made their presentations about tobacco, blood pressure, and cholesterol. And then a quiet professorial man with a funny last name and reading glasses that he pulled down over his nose to look at the audience as he gave his talk, presented the findings from the Longshoremen study. The findings, of course, showed that the high-intensity, high-volume workers had significantly lower risk for heart attack than workers with lower intensity and volume activity. The presentation was careful, compelling, and eloquent. It would be nearly a decade before I would meet him, but I knew that day that he and this topic were something special. The longshoremen study was published in 1977, and it joined a growing number of studies demonstrating the beneficial relationship between regular physical activity and a reduced risk of myocardial infarction. But just as these papers were being published, vigorous physical activity was leaving the work site. By 1972, the year the longshoremen study ended, mechanization and containerization had so changed the work of longshoremen that few high-energy tasks remained. The vigorous longshoremen had shown us that regular, high-intensity activity is healthful, and then they shifted to a less active lifestyle. By the middle of the 1980s, however, the course was set and we were happy about it. We liked knowing that vigorous aerobic activity reduced the risk of heart attacks. The next story, moderate butts in and the unthinkable happens, requires a short discussion about the rate of energy expenditure of aerobic activities. Within the past few years, we have mostly agreed upon the names and MET ranges for our arbitrary categories. Vigorous activities requiring 6 or more METs include running at various speeds, rowing, sawing by hand, and shoveling snow by hand. Moderate intensity activities at 3 to 5.9 METs include things like dancing, marching, and walking at various speeds. Light activities from 1.6 to 2.9 METs include standing and looking at art, strolling slowly, and many of our everyday activities, such as getting dressed, making the bed, cooking. Sedentary activities include sitting, reclining, or otherwise resting. These categories have been very useful. We have used them as convenient benchmarks for discussion, for epidemiologic analysis, surveillance, and public health recommendations. We should not forget, however, that rate of energy expenditure is a continuous variable. And like the transition of colors in the visible light spectrum, the point at which an activity becomes vigorous, moderate, light, or sedentary is arbitrary. At the end of the previous story, we had established that regular, vigorous aerobic activity reduced the risk of heart disease. New reports not only supported this finding, but expanded the list of health benefits. First, hypertension, colon cancer, type 2 diabetes, then osteoporosis, anxiety, depression, and now many more. Some of these epidemiologic studies indicated not only an expanded range of benefits, but an expanded range of beneficial intensity. Data from the Harvard alumni study, for example, showed a reduced risk of heart disease not only from vigorous activities, but also from moderate intensity activities. Another example, researchers in the Netherlands reported that people who reported year-round walking, cycling, or gardening experienced a reduction in the incidence of acute coronary events similar to those who performed vigorous intensity activities. Moderate intensity activity was butting in on the benefits previously claimed for vigorous activity. As the evidence accumulated, some of us were convinced more quickly and others more slowly that moderate intensity activity was helpful too. This landmark 1995 CDC ACSM recommendation that we now remember mostly for the 30-minute, 5-day per week suggestion was written primarily to establish consensus about the value of moderate intensity physical activity. the volume of activity recommended was, if not exactly an afterthought, of secondary importance. When the CDC recommendation was published, the most complaints were not about 5 days or 30 minutes or accumulation. They were about the loss of primacy of vigorous physical activity. It was very difficult to believe that merely moderate intensity activity, something as easy as walking, should share the podium with vigorous. So we drew a line so that nothing else could qualify. We had not thought hard enough about the continuous nature of the rate of energy expenditure. During the late 1990s and the early years of this century, the compartmentalization of physical activity intensities became rigid. The line between moderate and light intensity activities became a thick barrier, separating the so-called good activity from the bad. We had accepted moderate intensity, but we were not sinking any lower. And just as these categories hardened and the separation between good activity and bad activity became firmly fixed, the unthinkable has happened. Researchers controlling for the amount of moderate and vigorous activity have been reporting that people who are more sedentary are less healthy. And that means that light intensity activities are making us healthier too. Here's how I picture it, drawing upon data from several studies and not any one in particular. Let's assume we have two groups of people. They both sleep about 8 hours a day and spend all or most of the day in sedentary and light activities. And the group on the left here does no moderate to vigorous physical activity, and the group on the right does some. Now, if we take each of these two categories and divide them again, so that each group now has a subgroup that does relatively more sedentary activity here and here, or relatively more light intensity activity here and here. And now this figure is more complicated than I like to show at a session like this, where you don't really have time to sit and look at it. But I have added a set of bars in pink to show estimates of the relative risk of adverse health events such as metabolic syndrome and type 2 diabetes for each of these four groups. And what I want you to notice that for this group here that does no moderate to vigorous physical activity, the group that does more light intensity activity has a lower relative risk. And the same is true over here. For those who do some moderate to vigorous physical activity, the group that does more light intensity activity has a lower relative risk. We can only conclude that light activity provides health benefits too. We had begun 30 to 40 years ago learning that vigorous physical activity improved cardiovascular health. We had envisioned sleek and muscular bodies performing feats of endurance and strength. And today we have learned that the spectators, by occasionally standing and cheering, are improving their health as well. This is going to take some getting used to and some hard thinking about physical activity. Since about 1950, the year we began the story about the vigorous longshoremen, and the final 1/4 millimeter of our 200,000-year-long meter stick, physical activity, a behavior essential for healthful physiologic function, has withered. Major causes have been the Industrial Revolution and the Technological Revolution. The Industrial Revolution brought the mechanization of the textile industry and new methods of making iron, later steam-powered ships and trains, and of course the internal combustion machine and the automobile. The major scientific advances occurred in the 17 and 1800s, but it was not until after World War II that the size and economic prosperity of the middle class brought labor-saving devices into widespread use and began to obliterate routine physical activity. I realize that for many of you, 1950 seems like a very long time ago, but I, and at least a few others in this room, remember it clearly. And we, especially we, know that the 1950s were very different from today. I can remember helping my father shovel coal into our furnace, helping my mother do our laundry and hanging the clothes on the line to dry. My brothers and I took turns mowing the lawn with our human-powered lawnmower, and we walked to school every day. By the time I left for college, we had an oil furnace with an automatic thermostat, an automatic clothes washer and dryer, and a gasoline-powered lawnmower. But my younger brother, Raj, he still walked to school. I've heard Steve Blair describe his boyhood chores on his family farm in Nebraska. And here he sits astride his pony, ready to go out into the fields to bring in the dairy cows or to help with the planting or the harvesting. Here he sits with his grandson, riding a refurbished tractor, but this was the first tractor he and his family were able to buy in 1953 to help with their chores. As the machines from the Industrial Revolution became available, we took advantage of them and routine physical activity dwindled. We need not depend upon my selective memories. Several nice papers provide empirical quantitative evidence. Brownson, McDonald, Church, and others have documented declines in routine, moderate intensity activity in the U.S. For occupational activity, the proportion of people working in jobs categorized as requiring moderate intensity activity has fallen from nearly 50% to 20%, replaced by light intensity and sedentary job categories. And these decreases based on job category do not include changes in the way that a job is actually done, such as the shift in duties of the night watchman from walking the environments to watching the screens, or the policeman from walking the beat to riding their segways. For transportation, the proportion of children walking or biking in school has dropped from 45 to 15%. The average number of miles driven daily per person has risen threefold since 1950, and the proportion of people driving to work has risen from 65 to 90%. Activity at the home has declined both inside due to modern conveniences like the automatic dishwashers and prepackaged dinners, and outside due to items such as the power lawnmower and those noise and air polluting leaf blowers. If we divide the day using schemes such as sloth, sleep, leisure, occupation, transportation, household, since 1950, activity during sleep and leisure appeared to be unchanged. But moderate to vigorous activity during occupation, transportation, and household tasks has declined. The machines of the Industrial Revolution have enabled and encouraged this decline in vigorous and moderate intensity activities. The technology revolution in the past 20 to 30 years has brought invisible losses, changes less easily measured, but possibly even more sinister. While visiting my brother in Wisconsin last summer, I borrowed his truck to do some errands. It was a warm day, so I rolled the window down. And in order to do so, I had to turn this handle in circles, as shown by my brother's hand. And as I did this, I realized that I really hadn't done this, turn the handle like that, for several years. We pop the latch to the trunk with a button. We push a button to unlock all of the car doors. Other than for courtship behavior, when did you last walk to the passenger side of the car to unlock the door for someone? When was the last time you walked across the room to answer your telephone, to change the TV channel, to change the music you're listening to? Our desk work is even easier now. The keys of a manual typewriter required a much firmer strike than today's computer keyboards. And to get to the next line, you actually had to lift your arm, take hold of that handle, and move the carriage to the other side. Here is your cubby of the future where you will not have to get up to do anything. Thus, in the past 50 to 60 years, a time that for many of you seems like an eternity, for me is a lifetime, but is far too short for evolution to notice, the intensity and volume of routine physical activity has abruptly fallen. We have lost vigorous, then moderate, and now light intensity tasks. The energy expenditure of physical activity that for hundreds of thousands of years was about 1,500 kilocalories a day is now commonly half that for highly active people. And for many it is less than 1/3 its former level. And these numbers almost certainly are sinking even lower. The physical activity behaviors that kept us alive and healthy have all but disappeared. Sick populations. In works of fiction, stories often reach a point of great tension just before action and resolution. In Moby Dick, the white whale is sighted. In Banjo Patterson's poem, the man from Snowy River let the pony have his head. Were my stories fiction, we would be at that point of tension. Physical activity, our protagonist, a character of richness, depth, and beauty. A character to which we owe our success as a species and our health as individuals has withered. The character's fate, and possibly our own, hang in balance. Regrettably, I'm not the creative force behind a work of fiction, nor a soothsayer with access to the future. In a few minutes, as we leave this room, this point of tension will remain. As shown so well in the recent papers in Lancet, physical activities levels around the world are low and almost certainly falling. In my country and many others, they are at dangerously unhealthy levels. We have sick populations and something needs to be done. Jeffrey Rose's article, Sick Individuals and Sick Populations, published in 1985, is one of a few that consistently guides my thinking about public health. In the 1970s and 80s, the so-called developed nations were confronting a surge in the incidence and prevalence of chronic conditions such as heart disease, hypertension, type 2 diabetes. Professor Rose noted data such as these, demonstrating remarkably higher distribution of systolic blood pressure for the London civil servants than for the Kenyan nomads. And these, pointing out the higher distribution of serum cholesterol in Finland where heart disease was very common, than in Japan, where coronary heart disease was uncommon. Now, a common approach to prevention is to treat patients with the highest risk. And schematically, it looks like this. People with the highest blood pressure, the highest serum cholesterol, or for our case, the lowest physical activity levels are treated. If perfectly successful, the distribution of the risk factor within the population would look something like this. Professor Rose suggested that sometimes we need a different approach. When the whole population is at risk, such as in Finland in the early 1970s when nearly everyone had a cholesterol level higher than 5.1. Or in countries such as ours, where physical activity levels are well below those of our ancestors, we need a different strategy. When the whole population is sick, instead of treating a few on the fringe, we need to shift the whole population toward a healthier norm. We need population-wide prevention. What does population-wide prevention mean? And what would it entail for physical activity? Consider this simple causal chain for the potential prevention of stroke. In this case, stroke is caused by high blood pressure, which may be caused by lack of physical activity, which is caused by an array of social norms and environments, physical environments, and many different policies, regulations, and laws. The high-risk approach to stroke prevention involves the right side of this chain. It focuses on the individual and risk factors that are close to the outcome. Evaluation research designs are relatively clean. They usually allow randomization, which makes them more easily publishable, but they probably won't help much. The population-wide approach involves the left side of the chain. It focuses on the entire population and the risk factors that are far from the outcome. Population-wide prevention is never a single program. It is always a collection of complementary efforts across systems. Evaluation research is rarely clean because many variables cannot be controlled, and randomization is often not possible, making publication different. But for sick populations, this is the approach we need to take. It is worth saying a few more words about this collection of distal risk factors. They are the written and unwritten rules of society, and they determine our thoughts and our behaviors far more than we like to admit. They come about in many ways, handed down from generation to generation, foisted upon us by clever marketing, and sometimes from public discussion and debate. I have heard them referred to as our cultural corset because they limit and shape our actions. And we tend to think about these written and unwritten rules as unchanging and not under our control. What we fail to realize is that our corsets are always in flux. Today's corsets are different from yesterday's. As immutable as they may seem, our cultural corsets are always changing too. Most importantly, we can influence the directions in which they go. Here is one example where complementary interventions in multiple sectors have caused behavior change. In the United States, in the first half of the 20th century, marketing practices increased the per capita consumption of cigarettes. Over the past 50 years, combinations of educational, legislative, and legal actions across many systems have changed social norms, and consumption has declined. Finland may be an even better example of successful population-wide prevention. Over the past 40 years, a wide range of comprehensive community and national policy interventions have induced cultural changes previously thought to be impossible. For example, agricultural policies helped shift the emphasis from dairy farms to berry farms and moved consumption away from whole milk, butter, and cheese to fruits and juices. And the distribution of cholesterol in the population has shifted from the curve on the right in 1972 to the curve on the left in 2007. The incidence of coronary heart disease is less than half what it used to be. Well-executed, population-wide prevention heals sick populations. The one thing we can say with certainty about population-wide prevention of inactivity is that it must involve all segments of society. These specific changes will vary among countries, but here are a few likely themes. We need to take better advantage of both new and old media venues and put physical activity into the headlines. We need to redesign our communities to make them safe and attractive for activity, paying special attention to our playgrounds and public spaces. We need to re-emphasize human-powered transportation. We need our children to have opportunities for physical activity at school. It will help them learn. We need our workers to have opportunities for physical activity at work. It will improve health and productivity. We need the fitness and sports industry to embrace moderate and even light intensity activity in addition to vigorous. And we need our healthcare system to emphasize prevention, especially the importance of physical activity. If we are to escape from our long-standing emphasis on the high-risk approach to prevention and to achieve population-wide prevention, then we must recognize that public health is at the heart of all these changes. And we who think of ourselves as public health workers must realize that workers in these so-called other sectors are our public health colleagues, whether they know it or not. And we must learn from them and work with them to accomplish our prevention goals. Just a few minutes ago, I said that the character of our protagonist, physical activity, had richness, depth, and beauty. You may have dismissed my description as mere keynote speaker's hyperbole, but I meant it. Physical activity, the leading character in our stories, is as rich, deep, complex, challenging, beautiful, and worthy as any character. Physical activity infuses every aspect of our lives: leisure, work, transportation, home, or however you choose to subdivide the day. And the diversity of types of physical activity is vast. All the activities of daily living, plus things as different as weightlifting, marbles, rugby, bocce, swimming, yoga, and things between and beyond. And these many types of physical activity interact with and influence a wide range of physiologic pathways to keep our bodies and our minds healthy. Incredible richness, depth, and beauty. But just as we've been learning about the healthful richness of our character, it has been disappearing from our lives. What will happen? What will we do? Our most important actions will be what we do to make physical activity routine again. And our discussion about sick populations and population-wide prevention concern that. But fundamental to developing interventions is what we think about physical activity. What do we think about? What do we envision? What is in our minds when we say physical activity? Now, your posters, presentations, and discussions, your stories, will reflect what you are thinking. But before I stop talking and start listening, I want to mention just 3 topics that I'm hoping to learn about in your stories. First, of course, is how do we reconcile our long-standing romance with vigorous aerobic activity and the now established value of light-intensity activities? How do they fit together? How will we measure the dose? Will we simply, and I think wrongly, redraw that thick line that we had first placed under moderate and now place it under light? Or will we perhaps find that different intensities have different roles and find a pedestal for each of them? Will we be able to keep in mind that the rate of energy expenditure is a continuous variable and recognize gradations perhaps even within sedentary behaviors? Second, can we learn to measure physical activity from 0? Our research and our activity recommendations have always assumed a baseline level of physical activity somewhere above 0. But that baseline has always been fuzzy and during the past half century has fallen sharply. The inactive control groups of years ago, such as the less active longshoremen, were as active as the active groups of today. Today's improved objective measurement methods should help us begin to measure from 0. Third, will we think more about relative intensity? When we say intensity, we almost always mean absolute intensity. And for young, reasonably fit individuals, absolute intensity and relative or perceived intensity match up pretty well because the categories were developed for young, reasonably fit individuals. But our capacity declines as we age, so that an activity that is moderate when we are young, such as walking, requires a relative effort that is vigorous when we are old. And this same decline in capacity occurs as younger people become less and less fit. Now, the proportions of both older people and unfit people are increasing around the world, making it more and more important to incorporate relative intensity into our thinking. And I have to admit, as a member of one of these groups, I have a personal interest in this topic. We've heard stories about how physical activity maintained the physical and mental health of our ancestors, about how we learned about the value of activity and how activity has withered. We've also heard stories about the necessity of population-wide prevention for sick populations and about the richness, depth, and beauty of our protagonist. All this time, we've been thinking about physical activity. How will we think about it in the future? Now it is time for your stories. Thank you for listening to mine.